Hello and welcome to another special segment of THWACKcamp, how to monitor your network problem children. With me, of course, is Destiny. How are you doing?
I'm doing great.
You know, this is a really interesting one, right? Because there are certain types of devices in networking that require a little bit of special attention, right? Like
Definitely. A little bit more detail.
Give me an example of one.
Like a switch stack, for instance.
Right. I mean, it looks like it's just one device. It has one IP address, but it's actually a large number of modules that all have to be managed. There can be partitioning and a lot of other things and power rings and the rest of it that are part of it.
They need to be fully redundant. I mean, there's things that are logically we know, but we need to see it physically as well to know what's actually going on when you're monitoring them.
Right. So you don't monitor them just like anything else. They're not just a node with a CPU, and they need a little bit of extra detail. So they're not necessarily problem children per se, but they can have problems that are a little bit more nuanced maybe than a single standalone network.
And they're very difficult to see, so we need more of a visual way to actually see things. And with NPM 12, we're taking more of a visual take.
Okay, so we probably ought to spend a little bit of time learning how to diagnose issues for stack switches.
Definitely.
And then what do we really want for our problem children when they're having a tough time?
Well, we definitely need to have some help there, right? Like, we want them to be successful and to be everything that they can be, but that's going to take a lot of structure and diligence on our side. So,
okay, so give me an example with a stack switch. What would be a kind of thing that you'd want to remediate that you would detect through monitoring of a stack switch?
So if you have a broken daisy chain, for instance, and you don't have full redundancy, you need to be able to fix that. And with NCM, you'd be able to actually make a configuration change. If you're able to actually see or add in your switches, you can actually do that with NCM and then see it in NPM now visually.
Okay, so we should definitely do that. Let's find a switch that maybe has a ring problem for the configuration to stand up the ring, and we'll walk through how to do that with NCM, show the integration between those two. What other things tend to need a little bit of special attention in terms of network devices?
Definitely load balancing.
Ah, yes. That used to be kind of simple. Or maybe it just seems simple to me because when I start with it in a location, it's usually a fairly small requirement, right? It's like a couple of applications, or maybe I have a piece of dedicated hardware for maybe VPN concentration or something else where I'm distributing those endpoints across a kind of wide but not particularly deep, sort of horizontally scaled infrastructure, as opposed to lots and lots of elements. But really quickly, there get to be a lot of parts, right?
Oh, definitely. There can be a lot of moving parts, and you assume it's working well, right?
Right.
But you don't know how it's working. So, I mean, you may have something that is scaling, you know, at 4 or 5 of them, or at 80%, you have one that's at 20%. Well, that's not really load balancing at that point, and so you need to be able to visually see that.
Right, or you get a big chassis with F5 bezels all the way across it, and you don't know which ones are local and global traffic managers, the relationship between pools and pool management, and being able to not just know what each one of those pieces of gear is doing and how it's performing, but how they're actually logically related.
Definitely.
Okay, so then that would require some special monitoring. What else can require a little bit extra help?
Your VPN connections can be.
VPN connections? Oh, you mean, you're suggesting that that is just a thing for me. Why do I always say that rhetorical question? Okay, so the rhetorical question being, are you saying that you can have a remote office, which used to be happily connected with a BGP. Now you've gone to a more cost-effective solution of VPN over public internet, and now all of a sudden reachability for that office can be a problem?
That is correct.
Okay, I would agree that that is a problem child.
Yeah, I would definitely agree with that.
So we would use what?
I would use NetPath in my eyes, so that you're able to actually see this information and know when you're having issues.
Do you think they're going to let us talk about NetPath very much?
Very briefly.
Okay.
Very briefly. I mean, we know we cover it a lot, but
there's like 4 other sessions where we're going to touch on that. So we'll talk about it
briefly.
We'll talk about it just a little bit in context. And then the last thing we probably ought to do is that the children of our networks, the things that we care about on our networks, really tend to behave most of the time, right? They're green most of the time. And so we don't want to monitor everything like it's a problem child.
No, definitely not, because then it becomes just noise and red or green right there, and that's not what you want.
So maybe we could wrap up talking about how to organize and visualize and do things like differentiated alerting based on their status of whether or not we think they might be a problem.
And that's where custom properties come in, and your grouping, because then that'll help you be able to segregate those out and keep an extra eye on them.
Dynamic grouping is a wonderful, wonderful thing.
Yes.
Okay, so let's start with stack switches.
Sounds good to me.
All right. Stack switches for a very long time were something that we monitored pretty well, but I was surprised at Cisco Live how many customers are switching almost entirely to switch stacks. And why not just, for any size business, go buy a giant monolithic 128 port switch?
Well, because if any company is expanding, or if you have new additions to it, or moving to an office where you need to separate locations, you're going to have to expand. So if you get a big, huge switch and that's all that you have on there, you're not able to expand, or you're creating even more problems because you have to have different configurations to keep up with, and it becomes kind of a complex environment. By stack switching, you're able to add the blades in, add the ports, get everything going, sense of redundancy.
You're a growing business. You start with
a
a couple of modules and then expand as you need to, plus you get...
Quickly. That's the key, right? Like, you're able to expand quicker by having the stack switches than you are by rerouting and redoing with your switches.
Right, but there's a lot of, again, logical orientation and relationships between those elements.
Definitely.
So talk to us about, show me how we monitor those with NPM 12, because this is just really amazing.
So on this switch that you see, this is your normal summary view in NPM. So you see your basic information, your health and the ports and the status and the memory, and that's good. But what I really like is the current hardware health that's available now.
Make this a little bit bigger, right? And so it's actually showing me with the icon.
Yes, it's showing you the switch 1, 2, 3. And so what's great about this is that it actually shows you the fan, the power supply, and the temperature. So,
and if there's multiples, yeah,
it shows you them all. And so what this does is it helps you to actually keep that extra eye on your switch and your stack as well, because before we only seen the actual master. We didn't see any of the stack datas or anything that was back behind there.
Right.
So if you had a temperature sensor that was going bad or something that was going wrong, you didn't know. I mean, if it literally wasn't the master, we were just kind of, unless you had an OID and you were checking it that way on Universal Device Puller,
right.
But not a lot of people were doing that,
So in this case, we're interrogating, it's such an awful word, but we're interrogating the master. It's then giving us the information for the relationships. Then we're basically iterating through the connected modules and then getting the status information. And one of the things that I love here is that in this case, we can see that the status is normal. That status is not coming from us.
No.
That's actually the status as reported by the device. We're not overlaying our own statuses on top. We're just surfacing what would be the normal status and terminology or error conditions or something else that are part of that switch that you would see right from the command line.
That is correct. And the great thing is that we also have a history, right? So like when you're baselining and trending and going through, we'll actually give you all that information.
Oh, that one's been pretty stable.
Yeah, and so a lot of people freak out though when they see that, because they're thinking 107 degrees, this is crazy, because we're so used to 100 and 0. You know, like we're so used to, like, if it's 100, it's hot, like something's wrong. That's not necessarily true, especially with technical equipment, but I mean, sometimes that throws people off, especially if you're just monitoring and you just kind of see things, your mind just reverts back.
Okay, but so that's a great question. So in this case, that might indicate that I've got my HVAC sorted out, I've got my hot and cold aisles are working the way that they're supposed to, I have a really amazing, consistent traffic utilization, so the temperature is almost always the same. What would I use to detect spikes that are maybe outside of my normal view? Is that a baseline issue? Is that a report? I mean, what's the best way to kind of surface the long-term trends when things appear to be flat?
So when they appear to be flat, that's automatically going to be trending on the baseline that we do on the back side of it.
So if I go 25% over that extent and I'm alerting on the base and the extent above the baseline, it's going to send me alert.
Yes, and you can also adjust your thresholds too on your alert with the switch stack. So, and that's an out-of-the-box alert is on the temperatures.
Awesome.
Okay, and so now when we look at the actual network itself, you'll actually can see the alerts. So when you're troubleshooting and trying to go through here and you go to the network tab, you're able to see the flapping routes, you're able to see the topology, you're able to see the routing neighbors themselves that are connected. And then we can also see the routing details and the hardware health.
So in this case, before, each one of those would have been presenting, or maybe the master might be, and then you wouldn't have gotten for the sub-connected units. But in this case, it's pulling them all together, so it looks like a single switch.
Correct. And when we go into the switch stack view, which is new in NPM 12, that actually gives you that visualization that I was talking about, that you can actually see the redundancy. So over here, you see the stack ring itself. So we actually see that it is a circle. If it wasn't, you would see the red, you would actually see how it would actually have a break. And we can show you that here, where you see the stack data ring that's actually incomplete. So that actually helps you know that you actually are at a half redundancy. Now, what does that matter to people, if you're new into monitoring the actual visualization of it, or to know that? Something great is that if you're moving things around, if you're switching businesses, if you're moving over, and you don't have full redundancy, you need to know that before you start switching everybody over, because you're going to have somebody that's going to be mad.
Well, or you're new to an environment, and the outgoing team, or maybe you're expanding the team. The manager's like, "Hey, everything's great. We're all stack switches, full redundancy, power and data. Everything's great. It's marvelous. There's no red anywhere. Everything's great." It's great to hear that. But what's really nice is actually to go and do an inventory scan, go do a report, and identify the ones that you, in fact, are operating, like in this case, at a half redundancy or reduced redundancy state, instead of one of those modules fails, and now all of a sudden you have partition palooza to deal with.
And something that I used to deal with was that, and I know it sounds weird, but like at Cisco Live, I had so many engineers back me up on this. I used to know when a switch stack went down when it came up. Right? Like, that's when I would know, because it was like when it came back up and things were going and everything was going back, and you're like, wait a minute, and then you're trying to track down, when did it actually go down?
I have new devices on my network. Oh wait, no I don't.
Yes, and so it's something that for me to be able to have that out of the box alerting to let you know if you lose a stack or if something that's going on there.
Or there will be a really unpleasant surprise if you lose an element based on reduced redundancy.
And a lot of the times those are simple mistakes because people are unplugging the daisy chain.
Yeah.
So, I mean, it's like something that you can physically, make the mistake of, but when you're monitoring it, you don't actually see it. But now you can visually see if it gets unplugged, not placed in the right spot. We have a problem now because we actually have the loss in the connection.
It's pretty funny in the way that cables are done. Obviously, there's a couple of different options. And I was watching two engineers at Cisco Live talking about this, two guys that work together. And they said, we debate about this all the time in our approach, and we've decided it's like shoelacing. There are just certain styles, and each one of them, they can tell kind of how they're done. I'm like, wouldn't you want to actually be able to see how that's wired so that you could have consistency across all of your racks? And when we started talking about this, they said, this would be nice. I could do an inventory report and figure that out.
Well, and especially when we were at Cisco Live, a lot of people loved it because, like they said, they were just doing moves and they haven't seen some of this equipment.
Right.
So they've came in, or they're helping a branch office move some things over, so they don't know if this is really fully redundant. They don't know if they set it up correctly because it wasn't them that did it. They don't have any documentation on there. So what their first thing that they said they were going to do was, after they upgraded to NPM 12, was they were going to actually enlist all of their devices into there so that they have now a visual representation of the F5 load balancing and the switch stack so that they can see before they go in there and start moving things around so they can prevent damage onto the network. It's their environment, it's just not their team, right? So it's something to kind of bring everybody together.
Okay, so you touched on F5, and we definitely are going to talk about that. But let's go, one thing about stack switches. I mean, let's say in the example that we have where maybe a ring is down. We're running okay, but it's not configured correctly. The way that would have been done a long time ago is you would log into each system, or maybe you'd have to figure out which one was the master, connect to it, and then do your config against that system and hope that you had enough redundancy or logical connection between the devices that would actually push the subconfigs out to all the connected modules. What's a much easier way to do that?
So I'm glad that you said that you didn't know the master or the actual stacks behind it. So on the new switch stack view, you can actually see, this will tell you that this is the primary, or this is the master, and this will actually tell you that this is the standby. Now, if you don't have a standby mode set up, you won't see that there. But what I like about it is that it actually does show you that so that you know where we're coming from here.
So that's telling me when I ask it, hey, what's your IP address? It's actually saying that's the device that's been connected right there on that IP.
Correct.
As opposed to you watch the Mac bounce all around trying to figure out.
Yeah, and then that's a great thing too, right? Because now we're showing you the serial number and the MAC address of your actual master and all of your subs that are out there. So you're able to actually see the RAM and the CPU individualized also, so that you're not just seeing it from the master like we used to. So now you can actually see, like, do you have an issue such as load balancing, which it's its own type of load balancing that we're offering here for you to be able to see, like, the port usage and the information which that it's carrying and tracking.
Because it's got the model and the serial numbers, is that also going to give you your maintenance status, vulnerabilities like NIST for hardware, or all of the other inventory scans are going to work as well, because now it can identify the system.
Right, and something it also helps you to do to prevent is a model stack error. So sometimes they have a different model number that's actually in there, a different model itself, and that can cause an issue because of compatibility. And so, and a lot of times you won't understand that because everything looks right, your rings are set up, the power redundancy's there, you can see everything, but you're like, there's just certain things that aren't clicking and not working, and if you had this on here, you'd be able to see that you actually had a model mismatch.
Yeah, and that was one of the things that was interesting talking to customers was how many of you have not dozens of stacks, but hundreds of stacks.
Yes.
So you are, and I know I'm preaching the choir here, you are racking and stacking lots and lots and lots of modules, and you can accidentally get non-parity, non-homogeneous stacks. It's an innocent enough mistake, and until it's deployed, you don't necessarily detect it. So again, it's an opportunity to go look at your existing infrastructure. When you install NPM 12, you'll be getting that data, and then run reports to make sure that those are working the way you expect.
And then like on the power ring itself too, we'll be able to show you this power ring, and also if you had another power ring set up, we'd show you the redundancy between the two. But now if there is a problem, like you were saying on the redundancy, used to, like he said, you'd have to go into it command line, and go to the devices and figure this out. You come to this page first, you're able to see, you can see that there's an issue there. You'd be able to go into your configs tab, because this goes directly into the device, use NCM, upload a script, change the config. Maybe it's something that's happened and you can see that there was an actual change to the config. So you'd be able to actually click on it, roll it up, and go backwards. It's however you needed to work one-on-one with this device, all from one page. So when we went into this device, we looked at the summary, we were able to look at the network, the vitals, we were able to look at the actual switch stack, the alerts, and now manageability, right? So we were seeing the monitoring side of it, and now we're able to actually see if I need to manage this and go back because there's configuration change, I can actually, click on it, set it, import it. We can download the config to take it. We can actually tell it which one we want. We can execute a script and immediately remediate a situation.
Yeah, and that's really, really handy, especially if you're trying to get it back online. It's nice to be able to execute that directly. The other thing that's interesting here is you are making the changes against the master, right? And then it's pushing the changes to the downline devices.
Correct.
So ensuring that you're sending it to the right system is really important. And up here, because on this view, on this tab, right, this is one of the this config tab, or summary or vital stats, is essentially based on the master at any given time. So when I make the changes from here, from the execute script resource, it's going automatically against the master. I don't have to worry about which one. It knows. So if that changes, it's going to be deploying, like if I'm in a crisis trying to resolve an outage issue, or maybe I've ended up partitioning and I need to get that back under control, the first thing that it's doing for me is that logical organization to determine where I need to be sending those config updates.
Yes, and that's something that we really like about this, is that you're still in one location, right? So we understand how the stack works. We've built this around, how do we make this simpler for the IT professional to be successful and quicker at identifying issues that are complex and making them very simple to try to be able to fix.
And so that's going to be based on the regular polling interval for the, let's see, how does that work? So is it the polling interval for the master, and then it pulls that first and then kind of walks down the connected modules? Or does it essentially index the connected modules and it pulls all of them at one time?
So, as coming from the person who did the MIB database, so as the MIBs are actually pulled, it's a polling cycle for all of those OIDs at once. Same thing as we do, like when we do for UCS and things, we actually grab from the HTTP, the actual API of the product, right? But we ask everything at once. So that's the same thing with this, is it's just like you said, it walks down. We say, please start this. And we have a list of OIDs at which that it grabs, we get them back.
But it starts with the master and then walks down. So what's the largest number of modules that you typically see in a stack?
So 8, I've seen a lot of 8s. I'm sure there's way more out there, but I'm just saying, like, most of our customers that have been around there that I've ever been on, 6 to 8.
6 to 8, okay. So it's really not that much additional polling. It's not gonna be another 10 minutes. It's it's nearly instantaneous because it's the same multi-MIB poll that it would have made for the first one. So you're talking seconds added on to the overall poll, you don't have to worry about the master getting out.
It's not even seconds, it's actually milliseconds. So like and this is something that I used to have to tell people with the OIDs, when we'd actually send out the request and come back. So we're sending it to the master, but the master is always updated by the actual, the actual switch stacks themselves. So it actually updates its MIB tables. So it's not that we're sending a whole bunch of information through the daisy chain, it's just through the master.
So there's a table element that's going to come back with the children for that master. Okay, that's awesome. Okay, so when you think about things that are problem children sometimes, to me one of those would be devices that I cannot restore with the config alone.
Yeah, you're going to have the binary image and things of that nature.
And that's becoming increasingly common.
Yeah, it's increasingly common for sure, and it's been around for a while also. But the great thing with NCM, especially like even when you're doing your F5 load balancing, is that we're able to actually take care of those binary configs. And let me show you what they look like, because they're new to people currently. The one thing that I wanted to make sure everybody knew is that it's actually binary code, right? And so it's pretty easy to see what they are. But if you're new to our system, especially with the config list, you probably might be like, ooh, what is this? You know, and we've had a lot of people ask that one. So that's your binary. So you're able to actually back those up, deploy them out, schedule them, use them as a job. But when you're talking about like the big IPs and the F5 networking systems with load balancing, you want to be able to have backups of that information, especially now that we're able to actually monitor those.
Right.
Because now that we're monitoring them and you need to change something with the load balancing, now we're able to have a backup and be able to actually remediate or make the change and send it on out.
So if I have a hard down box, I send a replacement for it that's pretty much got a bare metal config on it or like a transport config. I can exactly replicate its original production status and bring the new system up without additional configuration.
That is exactly correct, and that is why NCM is one of the best products to have for especially any networker, because you're able to do that from a bare bones, have it up and running in less than probably 10 minutes.
And it's not just limited to F5 here, right?
No,
This is any binary image that's on a piece of network gear.
Vendor neutral, same thing as before that we have. It's just it's another offering of which type that we can actually grab configurations and images.
So I can back up my images. Do we have customers? I would think that one use would be, especially if you have security concerns or maybe compliance issues, where you want to verify that a particular, not just config, but the image itself has been blessed, that you'd be able to distribute a known good image directly as opposed to just sending it up from a TFTP server somewhere, right?
Right, yeah, and you're able to actually make suggestions on there. So you can like click on them, edit the configs. You can actually also, a lot of people put these in Script Manager itself and hold them there and for like outlines of how a baseline config has to be on your devices and things of that nature. You can use Script Manager to store those in an area. And you can grab them from the device or from Script Manager itself.
Walk us through how to get to Script Manager in case someone who's watching hasn't seen that before, because that is an extremely useful feature. I'll make this a little bit smaller for you. There you go.
Okay, so you go into your configs, and it's under the configuration management portion. And then, as you can see, you have the transfer, the inventory, and then you have your script management. Now, what's great about this is that you're able to store, add new scripts, add things of which that you need to do there. These will show up in any device config.
Okay.
So when you're in that little box that said execute a script, this is where you draw those from.
Okay.
It's from your script management. Now, something that I really love about script management is that from a security aspect, as well as just anybody that's in the trenches trying to keep up with things, it's easier to have a local location where you can comment on it. Anybody can have the accessibility of it instead of emailing scripts back and forth because
that never happens.
No. It's kind of like the white elephant, right? I whisper something to you, and then that gets a little bit changed, and by the time it gets back to me, it's not my script from the get-go, but it has my name on it.
And then I execute it in bulk against hundreds of devices.
And it has my name on it, and there might have been a failure, and that can just cause a lot of problems. And your problem children, right? So a way to keep them in line is to actually have the rule set, as you see here, that we keep to adhere to. So we can actually execute the scripts that are here. Everybody can visually see them. You can also make it to where like only certain people can edit them. Some people can see them. Some people can't see them. So it's very manageable from a security standpoint to be able to manage these.
Well, that's what I was going to ask, because you have workflow and approval processes for direct changes. So you're saying that also it's based on the administrator, engineer, those security roles as well, who can make changes to the scripts and who can't. So that's a great way of being able to do delegation. You can say, hey, you can execute a script. And I'm guessing in the previous page, and you can show it if you want, if they don't have the ability to change it, then that dialog that shows the script is read-only, right?
Right.
Oh, that's great.
And then also, if they're not even supposed to even touch or see the scripts, then when they come to the page, you'll just see configuration management, status, and inventory. It won't even give them the tab. They don't know what they're missing.
Okay, you've been teasing about load balancers. Let's walk them through how to actually manage a load balanced environment using, again, the ability to look at details that particular problem children might have.
Okay. So we'll actually go into the My Dashboards, Network, and then load balancing itself.
That is just so hard to find.
It is.
And that's a permanent link?
That is.
Well, it's a permanent link based on the view restrictions that are part of that view.
And here we go.
Okay, there we go. All right, so we have our load balancing environment here, and I can remember years ago, Chris O'Brien and I, once upon a time when I managed all of our demo systems, we got into a lot of conversations about load balancing. And anytime we would look at things like the total number of connections by virtual server, or number of connections by pool, or number of connections by traffic manager, for example, we would always have to go log into the dedicated UI and sit there in our swivel chair and change back and forth and back and forth. And the dynamic nature of load balancing is one of these things where you really do want to keep your eye on this.
Definitely. And something like you said before, when you had a small business versus going into a bigger business or adding more, things that which needs to be balanced out, you think you have it under control, but you maybe haven't seen it visually.
Okay, like for example, here we've got, this is our whole balancing environment, right? This is all F5 components. So I've got all of my different services across the top here, and I can see the status for each one of them and its name. I've got my GTMs, my LTMs, and then virtual servers, the pools that are connected to them, and the pool members. So at this point, we're really just talking about overall inventory and overall status over here in this column. So if I click on this node, so this is one of my GTMs, right? It's giving me a couple of options. Why would it ask me if I wanted to see the details or the relationships?
Well, there's two different things, right? So like you said, inventory versus relational data, of which how it sees itself.
Okay, so if I go down here and say show relations, it's going to tell me how this is connected. So in this case, I have what? A little bit of redundancy and a single point of failure, right? It's telling me that I have a single GTM here, and that the LTMs behind it are all connected to that one GTM. So I don't have redundancy distributed across multiple GTMs. It's telling me the virtual servers that are connected behind those traffic managers. It's also telling me the replication state, right? Whether it's standby, active, active, passive. In this way, it's actually standby, active, and in sync. It's telling me how many connections I have. And I can walk all the way down. So the virtual servers, the pools that are defined on those servers, and then the members that are a part of each one of those pools. So the first thing that I'm looking at here is I get a sense for redundancy, and where I see a pinch down to one point, I have got a single point of failure.
That is correct.
All right, so we talked about detail before. If I click on one of these nodes and say detail display the detail page, I get down to what would normally look like a node details page, but in this case, it's actually specific to load balancing. And for those of you who are using SAM, you've been using App Insight for a long time. So if you're connected to SQL Server, for example, you get lots and lots of details that are specific to SQL Server, timeout waits, longest running queries, a bunch of things that maybe aren't part of a typical monitor in an application template, but specific to the app stack view. So this is network stack, effectively, right? These are network-specific views now that are being made for to be able to deep dive into certain types of hardware. So in this case, it's giving me things like summary, like how are my sites and load balancers behaving. I can look at the details for this individual machine. Because I'm looking at the detail level, it's always going to give me my environment view. It's kind of like load balancing stack. You can call it that way, but it's giving me that. And then depending on where I get the detail, what level of detail, it's going to give me the performance at that level. So in this case, this is giving me things like DNS resolution by service, right? If I was looking at, for example, an LTM, it's going to give me things like the concurrent connections by virtual server. Right? And that's always one of those first things you should look at when you're load balancing is how many connections do I have on this box, and being able to quickly make changes like reassign the pool membership to address traffic congestion is really handy. And you can actually do that through this UI, right?
You're able to actually dive into the pool and say reassign.
Very, very handy. And again, here, because I'm on a local traffic manager, I get an LTM-specific summary, right? So just at a glance, I can check pool membership, virtual server, whether they're up or down. If some of these were up and down, I would get reds and greens.
Something that I like, Patrick, is that when you actually look at the concurrent connections that are there, is that when you don't look at these for a while, or say you're just now bringing it up, right? Because now we have this view set, we're able to pull this data. When you look at it, you'll sometimes see where everything is hovering up there, say 175 connections, but you'll notice like this greatly. One of them's hovering down there at like 50, 25. So you need to look at your configuration, right? You need to see how are you basing your load balancing on. Maybe you need to revisit that. Maybe you don't need to do it by, max connections. Maybe you need to do it by, fastest, reliabilities, things of that nature. So it's a good way to get a baseline for what your network needs are, because this may be the bottleneck for some of the applications that are coming there when it was supposed to prevent this from the beginning.
Or application-specific issues, right? Like if you have apps that are just more CPU intensive, you're not going to be able to run as many concurrent connections over those. So being able to monitor the application performance right there with your load balance performance is how you're going to be able to more evenly distribute those and deliver better load balance services.
And it's visually easy to see this. That's what I like with the switch stack and with the way that the actual F5 load balancing pages are, is that you're able to visually see now the information instead of just reading it. Because when you read load balancing or when you read how a ring's supposed to look, it's black and white and you're not visually seeing the connections or how they're doing.
Right. The other thing when you're looking at a service is if there are service issues that are coming from that environment, it'll actually surface that directly so you get the same text again that you would get if you were logged in directly to that system, because it's really important to know maybe the reason that the status of a service has changed and the details of which one have changed. Okay, I could talk about load balancing for another 15 minutes, but there's two topics that we teased briefly. One of those would be problem children. Those would be remote connected offices where maybe we've moved them from one type of network to another, or SaaS, and now we have the public internet involved in that path. NetPath is really handy for managing that entire service.
Definitely.
And for those of you who have not seen NetPath and are not watching one of the other segments from THWACKcamp this year where we're talking about it, just remember that that's under NetPath services. And a NetPath, for those of you who have never seen NetPath, is a connection between a probe and a service. So for example, here is the path to THWACK from Austin. So I have Austin on this side, and then running all the way across are all the paths and connections on the other side. So one of the things that's always a problem, wait, I shouldn't say that. I should be nicer about our friends at the ISPs. ISPs sometimes are providing, sometimes can be an issue in their internal routing networks. That is a child that's very hard to get to, but in this case, if there is a link that is down, it's easy to pick up the phone and address that.
And it's easy to track down that problem child.
Yes, and of course get the contact information of who you need to talk to over here. Okay, so NetPath, I would love to talk about that. In fact, we do get to talk about that in another session. And then the last thing, we've talked about this before, is not everything in your environment is broken all the time.
No, but definitely you want to be able to keep your eye on some things. So maybe you have a problem child that's, say, on the verge of being a problem child, and so we need to give it a little extra attention to get it back on track.
Or maybe you've got M&A, you've acquired another company, or you're being merged into another company, so things that have been stable for a really long time might actually need a little bit of extra care and attention. So one of the great ways to do that, and we've actually talked about advanced alerting a couple of times at SWUG, at SolarWinds User Groups, using custom properties. But you can also use those to flag, almost like create a isProblemChild custom property on interfaces, nodes, applications, whatever else, and then use your dynamic grouping to be able to break those out. There was one of here that was pretty
low free space.
Yeah, let's expand low free space. So low free space could be a lot of things depending on the context of what you're talking about, right? So here it could be something like volume, it could be the amount of memory, it could be physical or shared or storage, or a lot of things that can all run out of space. So I've created sort of a high-level problem child definition, but it allows me to do I can do different alert escalation policies. I can group them together. In this case, we're sort of looking at the raw group, but I could have a knock view, for example, where I use the dynamic tree view based on that group membership to populate my problem children into a dashboard. Would you have, in knock, would you have a screen that said problem children? Maybe just kind of put them all off, or would you?
I don't know if I put that on my knock screen because that's usually very visible.
That draws attention to things that don't really matter.
But one thing that's great about having that is, like you said, the alerting. But on top of it, if you're making changes or rolling out changes that affect certain devices, a lot of people use a custom property for these are the devices of which that we're making the change on. And then that way you have just a visualization, more alerts so that they're not alerting on everything in your group. And maybe you're wanting like a real fine, if there's a shift or if there's a change into it, you can apply it to that group. So it helps you on maintenances.
Ah, that's great. All right, so here's some of the problem children that we talked about. We talked about stack switches. We talked about managing changes to stack switch to address issues that are discovered through either alerts that are raised by a switch stack, or we do inventory to realize that maybe we're running in reduced capacity for a power or data ring using the NCM integration. We talked about the problem children that we can have with binary configs.
Definitely.
And how important it is to be able to manage those as well. We talked about load balancing, and that's actually not that big a problem if you can see and understand the relationships between all of the elements. And then last we talked about how to organize them.
Yep, then that's pretty much your problem children. I mean, there's several more there, but I think that we really focused in on kind of the main principle behind SolarWinds and NPM as well, is that we want to give you that visualization of actually these problem children so you can keep track on them.
So to leave them with some homework, what are some of the other sort of problem children that you might have to deal with? UCS?
UCS is one, because you definitely need to be able to see your switch A, switch B, your fiber interconnects, things of that nature, and we're able to do that in NPM.
Modules and all the other components. What else?
I would also definitely look at your fiber interconnects, because we're able to keep an eye on those. I would also try to keep track of all of your changes. So config change management is a huge one, because you need to figure out who is making changes and where and why.
That is hurting cats and definitely problem children cats.
Yes, definitely. But there's a ton, right? So even if it's on the virtualization side or if it's on your server side, I mean, there's things that are hard to reach and hard to get into there, but I do believe Leon's going to have a session on the hard to reach ones as well, so you definitely want to stay tuned.
He is again. So I think hopefully we've reminded you that a lot of the features that are in this case, NPM, are much broader, but also go really deep into specific monitoring for specific vendors and specific types of technology, whether it's load balancers or stack switches or UCS or fiber interconnects, where you get specific views based on specific types of problems. And those goes across many of the modules in Orion, especially on the application side as well. And so get in there and spend some time searching here on THWACK.
Definitely.
Ask other users in the forum if you suspect that there's a capability that maybe you're not using. Check out SolarWinds Lab and get in there and get your problem children under control.
Definitely. I think that we all should be getting that under control.